Hello everyone. The last video we discussed about the specifications of standard second order systems. Now in this video we see some of the problems related to time response analysis under unit 2 of control systems. The first problem, obtain the response of unity feedback system for unit step input whose open loop transfer function is g of s is equal to 4 by s into s plus 5. Okay, so in this problem here the open loop transfer functions are given and then feedback is unity feedback. The input is step input. Okay, now find the response. You can find c of t. Okay, so that you draw the diagram first. So r of s is the input. So summer block and then having the open loop transfer function 4 by s into s plus 5 with the unity feedback. Okay, connected in the feedback, unity feedback. Here you put c of s. So what is the transfer function? C of s by r of s. So output of Laplace of output to Laplace of input. So c of s by r of s is equal to g of s by 1 plus g of s. So 4 by s square plus 5s plus 4. Okay, this is our transfer function, given transfer function. So that the closed loop transfer function. So I am giving r of s is equal to 1 by s. So c of s is equal to r of s into 4 by s square plus 5s plus 4. So that I am replacing the r of s by 1 by s. So 4 by s into s square plus 5s plus 4. So you can find the roots for this one. Because 5 into 1, 4 into 1 is 4 and 4 plus 1 is 5. Okay, you can find the roots for this s. So having two roots, so s into s plus 1 into s plus 4. So that taking partial fraction a by s plus b by s plus 1 plus c by s plus 4. Okay, you can find the ABC value. So 4 is equal to a into s plus 1 into s plus 4 plus bs into s plus 4 plus cs into s plus 1. So taking common factor for both the sides. Okay, so put s is equal to 0. So that your a value is 1. Next put s is equal to minus 1. Your b value is minus 4 by 3. And put s is equal to minus 4. Your c value is 4 by 12 which is equal to 1 by 3. So now you can substitute a, b, c value in c of s. So c of s is equal to 4 by s into s plus 1 into s plus 4 which is equal to 1 by s minus 4 by 3 into s plus 1 plus 1 by 3 into s plus 4. Taking inverse Laplace transform for the c of s, we can find the c of t. That is the output response. So 1 by s is nothing but 1. So that 4 by 3 is a constant, keep it as it is. So 1 by s plus a, e power minus at, here a is 1. So that e power minus t plus, again this is also 1 by s plus a. So 1 by 3 into e power minus 4t, here a is 4. So this is the solution for the first problem. Next one is the position control system with velocity feedback is shown in figure. Find the response of the system when input is unit step. So this is a given figure. Here having 100, g of s is 100 by s into s plus 2 and the feedback system transfer function is 0.1s plus 1. Okay, you can find the c of s by r of s. You know the formula, this is a closed loop system. So g of s by 1 plus g of s into h of s. Here h of s is given and g of s is also there. So just substitute and rearrange. You can find the transfer function. This closed loop transfer function 100 by s square plus 12s plus 100. You can there is a partial fraction for this transfer function or before that you can apply the r of s. R of s is unit step. Okay, c of s is equal to r of s into this one. So that 1 by s into 100 by s square plus 12s plus 100. you're taking the partial fraction a by s plus bs plus c divided by s square plus 12s plus 100. So find the ABC values. As in the previous problem, you know this, what is the procedure for ABC. So similarly, you can find the ABC value. So A value is 1, B value is minus 1 and C value is 12. Substitute these values in this C of S. So 1 by S minus S plus 12 divided by S square plus 12S plus 100. So now you take a inverse Laplace. So before that, having some standard format, that is a S plus A divided by S plus A whole square plus B square format. You can convert this 1 by S minus you can S plus 6 split at the 12 into 6 plus 6. Okay, S plus 6 divided by S square plus 12S plus 100 plus 6 into S 6 divided by S square plus 12S plus 100. So that you can write this S plus 6 whole square, remaining 64 is there. So that plus S square, denominator you can split it like this. So S plus 6 divided by S plus 6 whole square plus 8 square plus multiply and divided by the numerator and denominator by in the third term 8. So okay, 6 by 8 into 8 into S plus 6 square whole square plus S 8 square. Okay, so that S plus this is which is nothing but the standard format, that is S plus A divided by S plus A whole square plus B square, which is nothing but e power minus at into cos dt. E power minus at is A is 6, B is 8. So e power minus 60 cos 80 minus 6 by 8 into e power minus 80. Here A is 6. A is 6 and then B is 8. So sin 80. So this is a output response. That is the solution for this problem. So next one is the third problem. The unity feedback system is characterized by an open loop transfer function g of s is equal to k by s into s plus 10. Determine the value of k so that the system will have a damping ratio of 0.5. For this value of k, determine settling time, peak overshoot, time to peak overshoot for unit step input. So the given data is g of s, that is the open loop transfer functions are given, and then damping ratio. So from this you can unity feedback also is presented, so that you first find the closed loop transfer function g of s by r of s. So g of s by 1 plus g of s, k by g of s is k by s into s plus 10, k by s into s plus 10 divided by 1 plus k by s into s plus 10. You can rearrange and find the k by s square plus 10s plus k, which is equal to, this is a standard second order system, which is equivalent to your standard second order system, omega n square by s square plus 2 zeta omega ns plus omega n square. So comparing the standard equation, so that omega n square is equal to k. Okay, 2 zeta omega n is equal to 10. So omega n square is equal to k, omega n is equal to root of k. So 2 zeta omega n is equal to 10. So that you know already what is the given zeta value is 0.5. So 2 into 0.5 into omega n is equal to 10. Omega n is equal to, now we can find the omega n, 10 divided by 2 into 0.5, that is equal to 10. So what is the k value? K value is omega n square. So that 10 square, that is equal to 100. Now k value is 100, omega n is equal to 10 radian per seconds. Next is settling time. You know the formula for 2% tolerance band, 4 by zeta omega n. So Ts is equal to 4 by 0.5 into 10, which is equal to 0.8 seconds. Similarly, we can find the 5% tolerance band. You know the formula, 3 by zeta omega n. So Ts is equal to 3 divided by 0.5 into 10 is equal to 0.6 seconds. So next percentage overshoot. That is the percentage overshoot is formula 100 into e power minus pi zeta divided by 1 by root of 1 minus zeta square. You can substitute zeta value for this equation and calculate the percentage MP, which is nothing but 16.31 percentage. The peak time TP is equal to pi by omega n root of 1 minus zeta square. You know the omega n and then zeta value. Just substitute and find out TP value 0.36 seconds. So this is the solution for your given problem. The next problem is a closed loop system is represented by the differential equation d square c by dt square plus 8 dc by dt is equal to 64e, where c is the displacement of the output shaft or is the displacement of the input shaft, and error E is equal to R minus C. Determine the peak overshoot, damping ratio and natural frequency for unit step input. Okay. So given differential equation is d square c by dt square plus 8 dc by dt is equal to 64E, where E is R minus C. You can substitute this here. Okay, taking the Laplace transform. So here the s square into c of s plus 8s into c of s is equal to 64r of s minus 64c of s. You can combine the c of s in one side and r of s is the other side. So c of s, you take the c of s is a common for 3 term. So okay. So c of s is equal to s square plus 8s plus 64 is equal to 64r of s. Now what is the c of s by r of s? 64 by s square plus 8s plus 64. You can compare the standard second order system, second order transfer function. So omega n square divided by s square plus 2 zeta omega ns plus omega n square. That is a standard, that is transfer function, second order transfer function. So omega n square is equal to 64. 2 zeta omega n is equal to 8. So you can find out the omega n from this. So omega n is equal to root of 64, that is equal to 8 radian per second. Next 2 zeta omega n is equal to 8. You can find the zeta value 0.5. From this you can find the percentage MP. You know the formula already, 100 into e power minus pi zeta divided by root of 1 minus zeta square. So 100 into e power minus pi into 0.5 divided by root of 1 minus 0.5 square. So which is nothing but 16.31 percentage. So this is the solution for this problem. So next problem is the unity feedback system is characterized by an, this one is the last problem also. So the unity feedback system is characterized by an open loop transfer function g of s is equal to 25s into s plus 5. Determine the rise time, settling time, peak overshoot, time to peak per unit step. Similar, same procedure you get to follow for the previous problem. So according to that, so you can find the zeta and omega n. So after finding out the zeta and omega n, you can find the rise time, settling time for different tolerance and peak time and peak overshoot. So you know the formula, TR is equal to pi minus tan inverse of root of 1 minus zeta square by zeta divided by omega n root of 1 minus zeta square. You can substitute, find out the value for rise time, which is nothing but 0.483 seconds. So next one is the that is a peak time. Peak time is pi by omega n root of 1 minus zeta square. So that you can substitute the omega n and the zeta value. So after substituting, you can find the peak value is, that is peak time is 0.75 seconds. Next one is the settling time for 2% tolerance bond. So that Ts is equal to 4 by zeta omega n, which is equal to 1.6. And similarly for 5% tolerance, that will be a 1.2 seconds. Next percentage MP is 100 into e power minus pi zeta divided by 1 minus zeta square. You know the zeta value, you can substitute the value and find the peak overshoot, which is 0.75 seconds. References M. Gopal, that is Control System Principles and Design. This is a and then Agarthan Gopal, and Ogata and Benjamin Hu. So these are all the references. So these are all the references I referred for preparing this video lecture. Thank you for watching this video.